Yeah, this is the team. Fatima on top. She handles all the outreach for the REDX labs, which I spoke to you about. She's a graphic designer.
Yeah.
Subodh, you can see he heads the REDX lab. Expertise areas are AR, VR, analytics, also teaches analytics.
Nice to meet you.
Sushant is not visible. Yeah, there he is. He is also into machine learning,
Yeah.
3D printing, multi-dimensional chap. Saurabh, though, you know. So we'll wait for a few minutes and then start. Yeah, I think 1 or 2 minutes and I think we will get going. Yeah.
Can't hear me.
It's working.
It's working now?
How are you, Saurabh? You're muted.
Yeah, this is the worst place to be muted, but yeah. So I am doing great. I am, pretty sleep deprived because I was preparing so much and I was so conscious about this. So yeah. But hopefully it would be worth it,
Well, it will, I'm sure.
Yeah. How are you, sir?
All good. I'm fine. I'm absolutely fine.
Yeah. I guess I won't, have this opportunity while I'll be presenting. So I just want to thank Kaustubh sir because
You don't have to thank me.
No, really, because you have been an inspiration, and you might not know that in the 5th year I also took innovation, and I was expecting that sir aayenge and will join you, but that didn't happen. But I was very very into this innovation and all those things just because of you. So thank you for mentoring.
You don't have to thank me for all that.
No.
Anyway.
All right.
All right. Fatima, I think in a minute or so, we are good to go. I can.
I'll be doing this presenter view and just let me know if presenter view is displaying or what. Yeah.
All right. I think Fatima, we should start 6:32, right?
Yes,
Good.
sir.
I'll share my screen. Meanwhile.
Over to Fatima.
Yes. So, hello everyone. Good evening. I'd like to welcome all of you and our guest speaker for today, Mr. Sourabh Bagrecha. To give a little background on Mr. Sourabh, he is currently working with MongoDB as a software engineer. He also has diverse work experience with companies like Geo and Springswork. He has completed his BTech plus MBA Tech from NMI-MS. Mr. Sourabh also specializes in full stack development with an unquenchable thirst for curiosity and believes in impacting lives one block at a time. And we're looking forward to his session on blockchain today. Over to you, Sourabh.
Yeah, so excited to be here. Just let me know, if my voice is coming, screen is visible.
Yes, we can see your screen and we can hear you too.
Yeah, that's great. So, hi everybody, I'm Sourabh Bagrecha from the city of Lake Udaipur, and I'm currently working as a software engineer at MongoDB, which is the world's #1 NoSQL database. One of the things I enjoy the most is building full stack apps using React.js, Node.js, and MongoDB, of course. So without any further ado, let's get started. So, now before we discuss what is blockchain, what is Bitcoin, what is NFT, and all that cool stuff, I just want to take a quick pause and explain how Twitter works, right? Because this is really necessary that we understand how the world was working before blockchain and cryptocurrencies came into existence. So Twitter is awesome. It lets you connect with people around the world. It provides you an amazing platform to share your views and opinions with others. Recently, it has around 217 million daily active users and approximately 500 million tweets. That's a lot. And it's really important that we understand this system to understand what is centralized systems are. What are centralized systems? So let us understand how Twitter works behind the scene. So Twitter has mobile apps, on Android and iOS. They have websites so that you can, access it on your iPad, your MacBooks and laptops, etc. So how does the process look like? Like what happens when you refresh your feed on your app? So the process is very simple. The user tries to open the app, they refreshes their feed, and that triggers a request to the server asking for a fresh new feed. The server now issues a query to the database to return a list of tweets based on some algorithm. This is owned by Twitter. The database sends back the tweets to the server. The server now will respond back to the client with a list of tweets that can be displayed on his feed. A similar process takes place for posting a new tweet. You post some data, you types in something, you press post, and what happens is it goes to server. It gets stored in Twitter managed databases, and the server returns back to the client. But who owns this data? Like, can you guess? Is it the users? Is it the governments, community? Or do you think it is owned by Twitter? But you created that, right? But you don't own it. And the answer is all of the data that you will ever create on Twitter will always be stored in a database that is owned by Twitter until and unless you delete it. But is that a problem really? Like, I'm fine with it, right? So let's take an example of Jack Butcher. This is Jack Butcher, who is really famous for his minimalist art and conveying thoughts through simple yet powerful illustrations, right? He has hundreds of So he had hundreds of followers on Twitter across many accounts. All of his art is on point and just makes so much sense. He has been posting consistently and putting a huge amount of effort and time in order to reach the audience and creating a brand for himself. But guess what? One day, some of his accounts got suspended for a very silly reason that violates Twitter policy. It doesn't matter what value you are bringing to that platform, right? It doesn't matter how big audience you have. It doesn't matter whether you are a celebrity or not. One strike by the central authority and you are out of the ecosystem. This is really sad. Your years of hard work and efforts go in vain just like that. This is very sad and unfortunately true for all the systems that are controlled by a central authority. You don't own the system. You don't have any right to your data. Let's look at this oversimplified banking process, I would say. We will be discussing what happens when you deposit money in the bank. Same process, like you fill out a deposit slip, you give it along with cash, you fill out then the cashier returns it to the reserves and stores it. After successful transaction, cashier updates your account balance and puts a verification stamp on the slip and returns it back to the customer. Right? But what if I tell you that on one fine day, you will be restricted to withdraw your money from your account? Or would be, a certain limit, 1,000 rupees, 2,000 rupees. That's the max you can withdraw from your bank in a week. That's too bad, right? God forbid. But how would you react when you get to know that your bank has gone bankrupt? Your years of life's earning has now went into, I don't know where. Sadly, you cannot do anything about it. Even when all of its assets are sold, all will you get is just peanuts when compared to your savings. List of largest US bank failures gives us an understanding of how complicated and how primary problem this is to be solved. Please note, I'm not making up any stories. Take a look at this list. To put things into perspective, the biggest company in India, Reliance, which is a conglomerate, has a market cap of 216 billion. Just imagine how many employees, how many workers, and how many industries it is impacting. And just 216 billion it is its market cap. And here, a bank went bankrupt. All of their assets were close to 307 billion. You can just understand how big that scam was. Just blindly trusting a central authority may not be a good choice every time. What makes you trust something? When you can see the proof, when you can when you can ask multiple people and majority of them agree with that, when someone who has experience or knowledge in that domain says that, or when someone you trust, doesn't need to be an expert, gives you that information. Now just hold your emotions for this slide for the next few minutes. I'll be coming back to it. But let us understand. Let's take a look at a story, right? It's time for a story. Since traditional banking has so many loopholes, and I am assuming like most of you are not born and brought up in Mumbai, you came here for college and jobs purposes. And since traditional banking has so many loopholes, you and your friends have decided that you folks won't be trusting any bank anymore, right? Or any third-party organization for say. And now you all will manage money among yourselves. It is very inconvenient for everyone to settle in cash every time. So what you will do is you'll keep a ledger. Therefore, you all decided to introduce a centralized ledger. Any one person from the group who volunteers will maintain that ledger, right? So in this case, C is maintaining that ledger. So when C gets to know about any transaction, C will simply append it to the ledger. A pays 100 to B, noted. D pays 700 to A, noted. C pays 500 to D, noted. At the end of the month, you all will settle in cash, right? So therefore, it is simplified. The whole process of transacting money is so simple now. But what happens if C notes down an entry that never happened? Because they might want to take advantage of this. They might want to increase their wealth. They just added a new entry like C paid A 1,000 rupees. But that was not the case. So at the end of the month, A has to pay additional 1,000 rupees just to keep the ledger valid. Since all the flatmates will strictly be following this, it is again a problem of trust. You cannot trust a single authority again. In this case, C was that authority. So what you decided is, let's decentralize this ledger, right? Everybody in the flat will have their copy of the ledger. So not any one of them can tamper with the ledger. Perfect. Any transaction happens, it gets recorded in the ledger, everybody's ledger, right? Hence, we need a mechanism. And now what happens is everybody adds an entry according to them. Like A adds an entry like I paid D 1 lakh rupees. Or maybe C says that I paid 20,000. But that was not the case. That transaction never happened. But they still are adding that to their respective ledger. Again, there is no consensus, right? Not everybody is agreeing with it. Like everybody is saying that is wrong and that is wrong. And most of your fights will start from baat paise ki nahi hai, but baat paise ki hi hogi. Now it's time to introduce blockchain. When transactions happen digitally, that too at a global scale, security is paramount. Consensus is needed. There should be some proof for it, right? A node is basically a building block of blockchain, right? A node is simply a device running the blockchain from anywhere in the world. Nodes are the devices that helps us in storing, spreading, and preserving blockchain data. To compare blockchain with our previous flatmates example, we are considering every user has only one node, like a machine that is running that blockchain. In reality, you can run as many nodes as you want. So we'll compare it with the blockchain and Bitcoin system so that it is easier to connect the dots. So we have a private key, public key, and a list of transactions. Everybody has that blockchain in their device. What happens is public key helps you in getting an address on the blockchain, whereas private key helps you in providing your identity. Like, hey, you own this address, and you can sign transactions based on that. Anyone having your private key is simply you. Never share your private key with anyone. Think of public key as your email address and private key as your password. Encryption with the private key is used to provide authenticity. So what happens is, if you are going to do a transaction, you'll just sign it with your private key, and that's it. The transaction is considered to be on your behalf. We'll see this in action later on, but for now, just remember, private keys are needed to sign a transaction. Otherwise, those transactions are not valid and cannot be considered on your behalf. Hashing helps in defining cryptographic signatures. So you'll need some mechanism to do that, right? You'll need some signing mechanism. We are using SHA-256 hashing algorithm for our blockchain. Once you pass anything to it, it just converts that text into a gibberish, right? It's a complete gibberish. You cannot understand what is there. So now, even if I add just a single zero, it just changes the hash completely. The best part about hashing is it is unpredictable, and hence it cannot be reversed. By looking at the hash, you won't be able to guess what was the text that caused this gibberish. But when you provide the same text again and again, it will provide the same hash. So for same string, it will again provide the same hash. But for even a slightest of the slightest change, like changing the capitalization, changing anything, will result in a complete gibberish. So that's too technical, I know. Just bear with me. I'll be showing you how to understand this in action. So all right, enough theory. Let us take an example where all your flatmates are running a new blockchain on their own, right? They can run it on their laptops, they can run it by renting a server on AWS, and anywhere. Now A, B, C, and D are running the blockchain on their respective devices. That's completely in their ownership. Suppose A wants to send an amount of 500 to D. What they need to do? For that, A will have to initiate a transaction. A will simply have to mention what is his own public address, what is the amount that he wants to give, and D's public address, because he's paying to D. Now, this whole transaction is passed through a hashing function, like again, that gibberish, and a 256 hash is created using that. Now that hash is passed through your private key, because it is very essential that it should look like that you signed this transaction. And since you only have that private key, everybody in the network will assume that you only signed this transaction. So you should be very cautious when you are signing something. Just make sure that you have confirmed the details. Now we will bundle all these things: the data, the SHA-256 hash, and the digital signature, and we'll broadcast it to everybody. So I'll send it to all of my flatmates, B, C, and D. We'll take out the digital signature and sender's public address to generate a hash. So from that bundle, I'm just extracting out digital signature and A's public key. Now we are generating a 256-bit hash using, summing it up. Also, we'll do again one thing special, like we'll also do it with the data plus 256-bit hash, and it will again generate a new hash for us. If they both gets an equal strings and equal text, that means the transaction is verified. We can trust that transaction. It comes from an authentic source. Once transactions are verified by all nodes, they will start the mining process to register this transaction on the blockchain. And this is how money is made on blockchain, right? You mine blocks, you verify some transactions, you facilitate that authenticity through it. So all of my roommates will start mining. They don't have to do it physically, but through computational power. All of the nodes will be doing this process. I just want to reiterate on this point. Building a block, which is also referred as mining, requires three things. the address of the previous block. So they will be having a blockchain in their own systems. So just last block's address, the data that needs to be stored in the block, and a random number. And you'll be surprised to know, but Bitcoin takes approximately 2000 transactions per block. But for the simplicity's sake, we'll only consider one transaction in this block. Combining this information and passing it through the hash function will return a text that could possibly considered as the address of this block. So that is about to be mined. So the block will get a hash. So think of it as a fingerprint, right? If you get the hash, you can extract out the block from the blockchain. So you'll try multiple different hashes. There is no shortcut of finding the hash of this block. We all will have to hit and try multiple random text, or maybe number in this case, in order to create an address. All we need is 9 consecutive zeros in the beginning of this address. And since hashes cannot be reversed and cannot be predicted, it's impossible to understand what will cause the first 9 digits or the first 9 letters to be 0. Even making a small change like I did here will cause a completely random hash, again unpredictable. And hence it is almost impossible to predict what will be the 9 consecutive zeros in the beginning. This unpredictability of resulting the hash is the reason of why blockchain is secure. You are doing some work, you are trying multiple hashes. There are billion possibilities there is just one possibility in billions that the hash will match. Now, considering the case of Bitcoin, there are approximately 50,000 nodes across the world that are actively trying to mine something, like mine the block. And all of those machines are trying to find the first 9 zeros in any hash. They are trying any random number. And what happens is this process takes a lot of time. This process takes huge computational power. And because of that, even with 50,000 machines, it takes 10 minutes to block just one, to just mine one block. The chances of getting the hash with 9 zeros, again, is 1 in a billion. As of today, if you mine a block in Bitcoin blockchain, you'll get 6.25 BTC, that is equal to around 2 crore rupees. So good luck with that. But that's a pure game of luck. You won't be able to find it unless and until you have tried multiple times. And that's why it is secure. So once that block is mined, I'll send it to all the other nodes. They'll add it to their blockchain. They'll verify like that number is still valid and still giving 9 zeros, and they'll validate all the details. And if it meets the condition of a valid block, all the other nodes will also add it to their blockchain, and hence all of them will stay synchronized. I know this was a lot of theory, but I just want to just want you to take away just one thing, that it is so hard to tamper with any information in the blockchain, right? It just takes 10 minutes, even for 50,000 machines, to mine a new block. Just imagine if you were to just change the second block in this blockchain. You have to change it, and because the next block depends upon it, you'll have to change that as well, because there is this address that goes into this hashing process, right? So it's just so impossible to tamper with the information. And even if you do, there are multiple the different blocks added to the blockchain, and you have to do again and again and again, and it's not possible, and it's not quite incentive to do that, right? Anyone could view any transaction, right? Like if you have the public key of that user, you can understand like, okay, what all transactions they have done. So there is this permissionless and transparency property of blockchain, that and since only public keys are recorded in the transaction, there is no question of vulnerability. Even if you have my email address, there is no problem with my account, right? You can spam me and do all sorts of things, but you cannot do any email transfers on my behalf, because you need password for that. So always keep your private keys to yourself. And with this process, we are just maintaining that security and privacy for all of our blockchain users. Again, immutability. I just explained like how difficult it is to change or tamper with any information. Any change like here, any change in the A second block will require a new hash for that. That will take 10 minutes. Again, the third block will require this address, so that is also changed. Again, that will require 10 minutes. And while this process is going on, the next 10 minutes, a new blockchain is being added to everybody's chain. So your chain seems shorter, and hence it is considered as invalid, right? So let's understand what is decentralized. There is no one single entity that is owning this blockchain. No one has to know or trust anyone else, right? If it's in the blockchain, it's valid. We'll assume this only, and it's completely decentralized. So the problem of giving our trust to someone like bank or maybe Twitter or someone else, it's just get eliminated. So and one thing I just want to mention here is we don't need to trust the blockchain. Blockchain eliminates the need of trust, right? This is the key takeaway we all should take is blockchain eliminates the need of trust from the system. So you don't need to trust any third party. Again, proof of work helped us in, keeping the blockchain secure. Not anybody can tamper with it. And any modification will again require a lot of, work and computational power, which is not really, appropriate for any hacker. Like, why would they do it? It doesn't give any money to them, right? So there are, every business and industry is different from each other. You don't want to, make your blockchain public and show your inventory to any random user and all of that. So you can use private blockchains for that. You can use hybrid blockchain for, having a supply chain management system. So only your suppliers know the information, and you can do all sorts of things. And for that case, we have like four different types of blockchain: public, hybrid, and private, and consortium. So without any further ado, let's take a look at use cases, right? When Kaustubh sir mentioned me like, hey, can you explain blockchain? And he very stressed on this point that, you give them use cases, give them actual applications, give them, reasons to innovate. So I'll be talking a lot about use cases. So now that, theory and all of that is over, we can jump onto some very exciting stuff. And this also includes NFTs. So it's already exciting. So let's understand categories of use cases. So there is static registries. You'll use it for, your notary systems, your patents, food safety. You'll just need some proof that, okay, this document belongs to someone. I'll take an example from this use case and explain you how blockchain can revolutionize that industry. But for now, just understand static registry is a very primary use case for blockchain, apart from, exchanges and transactions. Identity, like your KYC. If you want to give your KYC details to someone, it just gets stored on their database, and that's not quite admirable. So what you'll do is you'll do some sort of public key transfer. All you need to do is just send them your public key, and that will again authorize your KYC. We can use smart contract. Smart contract is very new, and it's making the whole system very convenient and very incentivized to use it. Like if you use smart contracts, you don't need to build your own blockchain. And this is really interesting because we are eliminating that trust factor, we are eliminating that centralized authority factor, and still getting all the benefits without deploying our own systems. This is really an interesting use case. Dynamic registries. So what happens is if you buy a new car, you just want to make sure that it is all the parts and all the things are from a valid source, and it will run from for years. But what happens is when you buy a second-hand car, let's say, or maybe any second-hand device, what you need is you need to trust that seller, right? If that's your relative, that's fine. If that's your local vendor, that could be a problem, and you might be suspicious. So we need to remove that liability of trust. So what we'll do is we'll create a blockchain, we'll record any transaction, any accident that happened, and any registry that it has in the insurance document, it should just get stored. And when you get the car, you just want to check whether this car has been ever, into an accident, and that's completely, visible and transparent for you. Now, for payment infrastructures, we already know there is this Bitcoin, and there are multiple companies which uses it for payment infrastructure. Multiple banks are doing POCs on this. They want to understand how this industry can revolutionize. Just yesterday, US made it legal to trade Bitcoins, any cryptocurrencies, which is indirectly showing us that it is a really prospective payment infrastructure. It could really be, and US being the leader in every case shows us that this is really promising. And multiple cloud services, this is very ironic that cloud services itself are selling blockchain as a service, which is again all controlled by AWS. So I don't know what they are going to do, but that is again a use case. And there are also Dogecoin, and other things are there. And those initial coin offering is also an application of blockchain. Now let's take the most interesting use case out there, NFTs, right? So I researched about javelins, right? The average price of a good quality branded javelin in India is approximately 5,000 rupees, 5 to 6,000 rupees. It just ranges in that. So what do you think would be the price of this javelin right on the screen? Like 5,000? Maybe 50,000. This is a second-hand javelin, right? So it should cost lesser than the actual one. But what if it costs 2 lakh? Actually, you'll be surprised to know that this blockchain is was owned by Mr. Neeraj Chopra, who was also the Tokyo Olympics gold medalist for javelin throwing competition. And the highest bid for this javelin was 1.5 crore rupees. So just take a moment and try to understand, when someone can buy a new branded javelin just for 5,000, even 50,000, they'll get the world's best javelin. Why would someone spend so much money? Like, you can get 3,000 javelins in that amount, right? Why would someone spend so much money just because an Olympic gold medalist used it? The answer is pretty ironic. The answer is, it is non-fungible. What is non-fungible? Non-fungible is anything that is not replaceable by any other identical item. So they could be associated with some celebrity, some event, or maybe some emotions are attached to it. There is this other value that is associated with it that cost it too much. Their valuation can sometimes be beyond imagination. Like, forget about cost of manufacturing. They are just valued at this amount because they are associated with some emotions, celebrities, or events. Can you guess like what this tweet got sold for? Like, what about digital assets? Like, can we buy the ownership of a tweet? Can we buy the ownership of some random image on the internet? I can just right click and copy it on my computer, and I can say I own that, right? Why would someone buy a digital asset? Like, digital assets doesn't exist in reality, so for their ownership wouldn't mean something, right? But how can we prove or track the ownership of a tangible of an asset that is not tangible, right? This is not tangible. This tweet is not tangible. How would you define the ownership, or maybe prove the ownership that you own this? So this is a very prominent use case of blockchain and smart contracts. So this tweet was sold for $2.9 million, more than that, because the Ethereum value has risen up, and it is worth more than that. You can of course take a screenshot of this tweet and tell everybody, okay, I own the first tweet on the Twitter, right? It is replaceable, but the reason is it is replaceable by any other screenshot. So if your friend takes it, it just means that, okay, I have this, I can this is completely replaceable. What sort of record you have that you can prove this ownership, right? And because only one copy of this tweet will exist on the blockchain, no one else would be able to prove the ownership of this tweet, apart from the one who bought it at $2.9 million, right? So you are tracking something. So Jack introduced his public address to the chain. Okay, I'm selling my first tweet ever that has been made on Twitter, and everybody started bidding on it. Okay, bidding on his public address. So the highest bidder, he just sold it to him, and that's how NFTs work. You just register it, and since we already discussed that blockchains are immutable, blockchains are decentralized, we can trust the blockchain, right? That no one else will ever have this ownership. So you are understanding, right? There is this emotion attached to it. Like the first tweet, what I would feel if I have the first computer on the world, right? It is tangible asset. I'll feel happy about it. I'll have that Macintosh old PC. I won't be using it, but just the ownership of it will make me happy, right? So there is this value attached to it. Again, I'm just reiterating my words because this is really important to understand what will it mean to digital assets. So again, this is a crazy use case of blockchains, which is NFT. So how can you trade NFTs? Okay, so NFTs are nothing but crypto assets that record the ownership of digital file. You can also sell your videos. You can also sell your some tweet or that we recently saw. And you can also you can also purchase the Mona Lisa painting, the first digital version of it. Whoever owns it can deploy it to blockchain and can put it on auction, right? So anyone on the blockchain can place a bid. The owner have full control on whether to sell it or not. But once sold, they cannot be reversed back until they pay a higher amount to it. So this is really interesting, right? Like NFTs making the feeling of having some owned good, like something that is tangible, and just making a digital version of it, which is NFTs. You can prove your ownership. So this is really cool in my opinion. So let's consider what is notary, right? So you all have been to some registry offices in your city. You want to buy something, you want to buy a plot or maybe an apartment in your city, and what you need to do is you just need to go to that office and just sign some papers and just pay the owner the amount, and it's all good, it's all registered there, right? But what if the notary person tries to tamper with it, right? What if the notary person tries to change the ownership to someone else? You cannot really do anything, because the only record that ever existed that records your ownership was in the notary, and that itself got changed. So you don't really have a new way of defining that ownership. You don't really have a way to say that, okay, I own this. But the expectation from a notary is that it should be tamper proof. There should be an historic record of ownership. So from where it began and who all has traded on this land or maybe apartment, and there should be a mechanism to prove the existence of this property, right? And we just saw in the blockchain that all of these properties are there. Proof of work, you mine block, it takes time. If it is there, it is valid. And if you want to tamper with something, it's just not possible. So all of these benefits are what blockchain provides. So notarization is always considered as one of the best use cases of this, right? Although in short term, we won't see the complete replacement by technology. There are some implementations in the European countries and even in Canada, but there are none of them has fully, replenished the previous one to this. So it's quite interesting to see how it goes. But for now, it is a really interesting use case for that. So, blockchains are there. All of the notary systems in the world will have to, download this blockchain, and they'll store all the documents. And it just makes it the more and more people or the more and more organizations adopts it, it just makes it more secure, right? So that's again an interesting use case there. Now, let's consider this electronic voting system. So yesterday was, this Vidhan Sabha elections in just the results of these 5 elections were published. And in every election, whether it is Vidhan Sabha or Lok Sabha, whether it is in UP or any other state, many things have changed over time, right? If you go back to 2007, 8, or maybe whatever election used to happen at that time, they all have changed to a certain set. But one thing that has not changed is the consistent allegation on the Election Commission of India by the losing party. All right. So if BJP won, Congress will, assume that EVMs were hacked, or will pretend that EVMs were hacked. And if Congress wins, BJP will do the same thing. No matter what, as long as the elections are governed by a single centralized authority, building trust among all the users is not possible at all. Like, how would you do that? Just tell me, like, how would I trust someone else, like, who is not my relative or who is not someone I know? Why would I trust the Election Commission of India? Because it is owned by government. So government authorities doesn't do any frauds. So how would I, have that confidence over the system? So it is really important that we understand that building trust among all its users is not possible for any central authority, right? Your bank takes away all your money and you cannot do anything. All of your life savings are now gone. How would you trust a central system, right? So if in this case, fair elections are essential for democracy, and blockchains can really help us in making sure every vote counts rightfully, right? So how would you define a blockchain-based electronic voting system, right? You want all these benefits, right? Decentralized, immutable, proof of work should be there, traceability should be there, privacy should be there. But how would you, create this system? So blockchain-based EVMs can really play a huge role in conducting decentralized elections, right? All of those voting machines can have a decentralized node. All those votes are getting, mined, and all of those things are, happening as per the compliance. And since everything is public, it is really easy to trace any vote. So if any party asks, like, hey, I should have gotten these 300 votes in this ward. Why didn't I get that? So that can also be traced, because every transaction is public. But every transaction is public. Same way your email is also public. Anybody can send email to you, but only you can access that. So only you can vote on your behalf, but no one else can, vote on your behalf. So that's really promising use case. But the reason this system is not getting implemented worldwide is because you need a mechanism to store those private keys in a secure manner. Like, how would you, how would you facilitate that? What if there is, someone puts a gun on your head and asks you, like, vote this? So what would you do in that scenario? And if they ask you for your private key, how would you protect that? So that is really a key concern, because the voting system is not really in existence, but it can really be, as I showed. So, okay, but Saurabh, if I ever want to create an app that can leverage the benefits of blockchain technology, do I need to create a whole blockchain network on my own? Like, do I need to, give server to everybody and use my app? How would I, go about it? Do my users need to run their own servers? Every user, like even your freemium users, even your paid users, all of them will have to create a server on their own? Like, well, there is an easy way to get about it, right? So introducing decentralized apps, smart contracts. All you have to do is define some rules, right? So how would you want a transaction to happen? What kind of transaction fee you want to have? What kind of, electronic voting system you want to have? What is the duration between the election happened and the results publishing? All those rules you'll define in that app. You'll do some programming of that. There is a programming language called Solidity, and all you have to do is define some rules. And because blockchains are immutable, because blockchains are decentralized, and there is a proof of work, and since they have this transparent ecosystem, You don't have to really reinvent the wheel on your own. All you need to do is deploy your app on the blockchain, and it just gets away with it, right? So just as any developer can build apps for the App Store or maybe Apple's iOS operating system, developers can also build on top of Ethereum's blockchain infrastructure. This is really, necessary to understand that anybody in the ecosystem can build those apps. Anybody in anybody who wants to create an app but just don't want to invest in this huge infrastructure and doesn't really expect the users to have their servers on their own, they can really have this this architecture in benefit of them. So I would like to end this presentation now, and I'll be happy to answer any of your questions. And yeah, thank you for having me.
Thank you, Saurabh, for this informative session. I think everyone here has learned something really new.
Yeah.
And we'll have a lot of doubts, of course. So we'll keep the floor open. Participants, you could post your questions in the Q&A section, and we'll try to answer all of them if possible. Okay, so I think I'll start with this Q&A thing.
Yeah.
So we've seen that Bitcoin can be used as the next currency.
Yeah.
But there are too many cryptocurrencies on the market right now. So you could say that the Bitcoin is like the legacy coin, like the US dollar, which could be used as an interchanging thing. And you've got other coins which have specific use cases.
Yeah.
But then, how do you make all of that into one single system? Is there something in place, or we'll have to use them separately?
Yeah, so this is really an interesting question, and I'll be happy to answer it. But before that, I just want to reiterate on the point that blockchains are not owned by a single entity, right? And same is the case for any coin. So what happens is when you purchase a coin through Binance or maybe WazirX or any cryptocurrency exchange, you are not purchasing it from them. You are purchasing it through a mechanism, through a blockchain only. All WazirX is doing is buying that Bitcoin from anybody else who is selling that on the blockchain network, and they do it in a batch processing manner. So what happens is let's say Elon Musk tweeted about to the moon, and suddenly hundreds of users are asking for Bitcoin. They'll go to the Binance app or WazirX app, and they'll place an order, and there is this another group of sellers that want to sell. So what happens is it again is a supply and chain mechanism, right? But to answer your question, how would you facilitate a platform or something like that can combine all these coins? The answer is that shouldn't be the case. That is not ideal to have all those coins in a single authority. But what can happen is a single maybe a payment gateway or a single cryptocurrency exchange can provide all of those coins in a single platform, but they cannot really own all of that, because again, the reason we are using these coins is because we just don't want to trust a central authority. We just want to have it as trusted, as a trustless system as possible. So I don't know if I answered your question, but yeah.
I get your point, but I'll just follow this up with do you think that this technology is mature yet? Because if you look at Bitcoin, the price fluctuations have been you might have seen the fluctuations happening, and that is because people buy in bulk and then they try to dump it to get the profits. So if you can't trust banks, you can't even trust Bitcoin because of these fluctuations that happen. So what is your say on that?
So what I'll say is, don't buy Bitcoin because you see it as a promising equity sort of investment. It is not really meant for that. Bitcoin was made to facilitate transactions between different people on earth, right? You can barter a car and just take some Bitcoins in exchange. It is built for that. But what happened in the recent scenarios and what happened in the industry was people started using it as some sort of equity. So what happens if you buy a Reliance share, there are only a number of Reliance share in the world, or maybe in the NSE or BSE exchange. What happens is, if you purchase that stock, you'll have that ownership. If you want to buy that stock, you'll have to have some seller. Otherwise, you won't be able to buy it, right? So there are 100 sellers, there are 100 buyers, and you just have this exchange between them. If the sellers are low, the price will go up. If the sellers are high in comparison with the demand, the price will again go up or down as respectively. So what I'm trying to say here is that those fluctuations are not there because it is based on blockchain. That is not the case. Those fluctuations are there because people have different interests, people follow trends, people get influenced by some celebrity, and what happens is, based upon those assumptions, the prices go up and down. But blockchain doesn't have to do anything about those price fluctuations.
Right. Yeah, okay, I get it now.
Can I ask a question?
Yeah.
Okay. Hi, Sushant. Yeah. Hi, Saurabh. Yeah, my question is now blockchain removes the centralized intermediary, correct?
Yeah.
Now, but it also introduces multiple nodes which process which kind of validate the transaction, deal, whatever it is, right?
I understand. Yeah.
So now that means the intermediary, like a bank, gets replaced by multiple intermediaries.
Yeah.
Right? Okay. And the ability to mine a transaction depends on the computing power that you have at your disposal. Correct? The speed at which your processor works, the speed at which your node works. Correct?
Yeah, I agree.
So now an individual miner like you or me will have limited computing power as compared to a company like an Amazon or a Google.
Yep.
Right? So what stops these large corporations to become large-scale miners and they becoming the new intermediaries rather than a bank which takes 1.5% of my transaction today?
Yeah.
Wouldn't these guys become the monopoly tomorrow and also start charging the same transaction fee?
Yeah, that's a really good and very complex question, and it only comes when we go in deep. So I would like to answer this in this way. What happens is, if you are running a blockchain node, you just want to get incentivized at some day, right? If you were to block if you were to mine some blocks, or you just want to get the transaction fee or block mining reward. But for companies like Amazon, Google, and all of them, they have multiple servers. They have these huge cloud infrastructures, and all of that is there. But the problem is that there is no financial incentive for them. Like if the price goes down, like the currently 6 BTC gives you around 2 crore rupees. And if tomorrow the price goes down and if it only gives you 2 BTC, the return on investment is not that much. And the price of and the reward that gets determined is because the complexity of the network. If the network is able to solve it easily, the reward would be lower. If the network is able to isn't able to solve it easily, the reward will be high. So what happens even if these multiple big players come into this, there should be a stable return on investment they should get, right? Because what happens in these cloud infrastructures is that there is a lot of capex, right? You need to invest a lot of servers and all of that. And if that doesn't get used in Bitcoin mining or all of that, they need to have some, escape plan. They need to have to sell those servers. So this is really risky investment for them because the price of Bitcoin is not there, and they don't want their investors' money to spend on something that is not really, stable return on investment. So I would like to answer it in that way, because it is not a very incentive plan for them. They don't use it. but that is a really good idea. I just want to drop one really good fact. There is this huge mining space there in Canada and also in Dallas and Texas. What they do is they have multiple servers. All they do is they mine bitcoins. They don't have computers or something like that. They just have a server with a fan that goes out, that just blows out hot air, and they have some cooling systems, and all they do all day long is just mine bitcoins. And that is really giving them returns on investment. But again, they cannot always just predict that okay, currently I am running 5,000 nodes, I'm earning around $10,000 a day, so it's fine. But what happens if the price of Bitcoin drops tomorrow? There is no incentive for them to keep doing that. And because of this very reason of not having a stable ROI, again, they are not doing it.
All right.
Mhm.
Thanks.
Yeah, we have one question from Mr. Sagar Deshmukh. He asked how startups can introduce blockchain at early stages.
This is really hard, because this requires a lot of investment in educating people. This requires a lot of investment in convincing others to run their own nodes. But again, the last slide that is still open on the deck is saying that just deploy a smart contract. It is just the same as there is this Ethereum blockchain all over the world. What you do is you just deploy your app on that blockchain, and any transaction, anything that happens. So let's take an example. You want to create a startup as a notary, right? You just want to create a notary startup that does this on the blockchain. What you'll do is you'll deploy a smart contract. What that smart contract will have? That smart contract will have your rules, like anybody can only have possession of only one property, or maybe a property can be owned by only single person, and this would be the transaction fees, and this would be and all those criterias that you want, and all those business logics that you want would be there, right? So what happens is, once you deploy that app on the blockchain, any user on the blockchain can use it. But there is this another facility that is provided by blockchain, is called decentralized app. So what happens is, it just gives you a web interface. It just gives you a protocol to interact with mobile apps, and it just simplifies that process. So what happens is, you are leveraging all the properties of blockchain, like immutability, decentralization, proof of work, transparency, privacy, but you are still not investing on creating your own blockchain. You are just using that service. You are just using or maybe I would like to say this in this way, that this is the best of both the worlds. You don't need to invest too much on the education and customer acquisition, but you can still get incentive as you grow. So it's just a service as pay as you go, like cloud services we have. But one thing to note here is, it is not it is not centralized. So again, you have the trust of your users, you have the confidence of your users. Yeah.
So it's just like blockchain as a service that you mentioned earlier.
Yeah, but that was owned by AWS. So AWS
Right.
creates that. But here what is happening is, it is maintained by people like us.
Okay. Yeah. So I think we're very close to the end time. So before we log off though, I'd like to thank our speaker, Mr. Sourabh Bagrecha, for accepting our invitation and for being here with us today. Blockchain is something all of us have heard of, but never understood fully. This talk of yours shed light on the topic, and I'm sure everyone took note of all that was explained today. I'd like to thank our director, Professor Dr. Uday Salunke, for his support and guidance throughout the event. A big thank you to Professor Dr. Kaustubh Dargalkar for initiating the talks and bringing Sourabh on board. I'd like to thank the IIC team members, Dr. Vaishali Patil, Dr. Garima Sharma, Mr. Sagar Deshmukh, Mr. Amaya Welingkar, and others for their efforts. I'd also like to thank the entire REDX team for smoothly conducting the session. Lastly, I'd like to thank the participants who attended this session. And I hope this event was helpful and you learned a new skill today that can be pursued in the future. with this, we formally conclude the session. Thank you everyone once again for being here. Take care and see you all next time.
See you.
Thanks, Saurabh. Bye.
Thank you. Thank you, everyone.
Thank you. Thank you.
Thank you.
Bye.